Okay, in this presentation we are going to look at confidence intervals. Sorry, it's confidence intervals and not hypothesis testing, which it suggests at the top. So we are going to construct a confidence interval for the difference between two population proportions, pi 1 minus pi 2. Pi 1 is the population proportion for the first population, and pi 2 is necessarily the proportion for the second population. And essentially what we're interested in is the difference between the two. Okay? Now the point estimate is the difference in the sample proportions from both groups, which is p hat 1 minus p hat 2. Now, the estimation requirements. So the approach described here is valid wherever the following conditions are met. Both samples are simple random samples. They are independent and they contain at least 10 successes and 10 failures, and the samples comprise less than the 10% of their respective population. So that's essentially matters relating to the correct use of inference procedures in these scenarios. Now, just as a quick remark, this is the structure of a confidence interval. Point estimate plus or minus the quantile times the standard error. That's consistent the whole way throughout these whole set of exercises. Now, so I'm going to focus in on standard error for difference of proportions here. Okay. Just as a quick remark, this is actually specifically for confidence intervals. Okay. There is actually a slightly different version of this when you are doing hypothesis testing. Now, so SE, standard error of p hat 1 minus p hat 2, that is equal to two terms added together. Okay, and you should be familiar with them if you've done the standard error for one sample proportions. So the first term is p hat 1 times 1 minus p hat 1 over n1. So the first sample proportion times its complement divided by the sample size of the first sample. And likewise, the sample proportion for the second group times that complement of that divided by the sample size of the second group. So we have both of these expressions here. What we do is calculate both of these expressions, add them together, and then get the square root. Okay? So p hat 1 and p hat 2 are the sample proportions of group 1 and group 2 respectively. n1 and n2 are the sample sizes of groups 1 and 2 respectively. Now, you should actually sort of see something like this in the back of the exam paper, or some sort of log tables or something like that. That's fairly consistent because it's not something you easily remember. Just as a quick remark, there's no accounting for small samples in any of these questions relating to proportions. They are assumed to be, large sample procedures. Okay, so we don't have to worry about that. So here's an example. Difference of proportions. An example: a study of finds that a percentage of 40% of IT users out of a random sample of 400 in a large community preferred one web browser to all others. Okay, in another large community, 30% of IT users out of a random sample of 300 preferred the same web browser. Okay. This is a bit old-fashioned question in terms of technology, but this is the thing that people used to talk about back in the old days. Compute a 95% confidence interval for the difference of proportions of IT users who prefer this particular web browser. Okay, so 95% confidence interval. So point estimate, there we have it again. Point estimate plus or minus quantile times standard error. So that's the general structure of the confidence interval. So the main job really is to calculate the standard error, because that's the main bit of work. So that's what we look at first. So the standard error, that's the formula that we just talked about there previously. Just as a quick remark, what we could do is actually work in terms of percentages. So the only thing that's sort of different there, or I've slightly changed, is express the complements in terms of 100 minus such and such. So that just actually, rather than 1, so if we're dealing with percentages, which might be easier here, we just have to change that 1 minus p hat 1 to 100 minus p hat 1, because we're denominating our percentages between 0 and 100. Okay, so the first group has 400 people. The second group has 300 people. The percentage of the first group who like this particular browser is 40%. That means complement of that is 60%. For the second group, let me get this, it is 30%, which means the complement is 70%. Okay, so that's our two calculations. 40 times 60 divided by 400, that is 2,400 divided by 400. And 30 times 70 divided by 300, that is 2,100 divided by 300. Okay, good. So that is 6 plus 7 essentially. 2,400 divided by 400 is 6. 2,100 divided by 300 is 7. So the standard error is essentially the square root of 6 plus 7, which is great that we picked such nice numbers to work with. Okay, so that's the square root of 13, which we're going to just call 3.6%. Okay. Now, so the point estimate is the difference in proportions, the difference in sample proportions, p hat 1 minus p hat 2, 40% minus 30%, that is 10%. We have a large sample, that's always going to be the case with these proportions questions, and the confidence interval is 95%, therefore our quantile is 1.96. Hopefully you should be familiar with that. So, putting it all together, point estimate is 10%, okay? The quantile times the standard error is 1.96 times 3.6, that is 7.05. So it's 10% plus or minus 7.05, and that gives us our final answer down here, which is 2.95 as the lower limit and 17.05 as the upper limit. Okay. That's it. That's this question done.